We're stopping the wave.
Here we go.
Do you have my AirPods?
Boys and girls, the sooner we get to it, the sooner you get work time, okay? Makers of a generic aspirin are interested in a level of quality control to determine if there is a correct amount of an active ingredient in each pill. Does anybody know the active ingredient in Tylenol?
Acetaminophen.
Acetaminophen. Does anybody know the active ingredient in Claritin? So, pills have certain ingredients that are active that kind of help the body. The rest of the pill, that pill is things for such as digestion and say having a delayed response and whatnot. But so we want to test to see, okay, we're not going to sample 1,000 pills. That would take a long time. So we're just going to sample 36, okay? Sample 36 at random. Very important that that happened at random. And this is what we get. I think I actually have 33 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I do have 12. I typed it in wrong in my calculator, in my program, I guess. We'll just do the example, however, okay? All right, so we have the sample. The sample does not tell us the mean, and it does not tell us the standard deviation. So it says construct and interpret a 95% confidence interval for the average amount of active ingredient in each aspirin. That's what we would like to say to be able to give a solid answer in this situation. So I need to come up with two things. Number one, I need to come up with our mean, and I need to come up with our standard deviation. And so what I've done already to try to save time is I typed all this information into a Google Sheet, okay? Because there's something in addition I want to show you here. Now, I made a mistake. I was just doing this last hour. I only got 33. So everybody okay if we change our sample to 33? Everybody good with that? Okay. So I want you to show this here, okay? I grab this data here, and if I want to determine the mean, what again do I type? Good, equals average. I guess that. I got 321.39. Go ahead, write down 321.39. What else do I need? And so STD. And it grabs the same thing for me. I got 2.726. Are we okay with that? Now, here's something that we didn't talk about. And I'm not going to have this that you're going to be tested on for this test, but it is something we might reference in our final unit that we have before winter break. And that is this. Before we go ahead and we apply this t-test to all this, we should see if the distribution is normal. And so we did this once upon a time, and I just want to see from your viewpoint, I want to just see, do you remember this or not? You tell me. And if you don't, that's fine, but I just have to know what we have to build in after break. I'm going to select this data here, and one thing I'm going to do is I'm going to actually put it into order. I'm just going to copy this data into another spot, and here it is, and I'm going to sort it. Have I showed you guys how to sort something before? Watch what I do. It tells me a sort option. A few teachers came and asked me the other day about how to do this as well. This is a life skill. I don't want to sort the entire sheet. I just want to sort just this range. So if I said sort sheet, what it would do is it would move 328 to the bottom, but it would also take everything in the second row and move it to the bottom as well. You see what I'm saying? So if I just say sort range, it's only going to sort these numbers. So I sort those numbers, and now they're in order. Okay, so that's the first thing is sorting. Here's the second thing I want you to see is we're going to test to see if it's normal. Do you remember doing this? Copying it, pasting it into the normality sheet. Remember this guy? All we did is we pasted the data. Again, I'm not going to have you do this on this test. We put the number of data up here. How many data do we have? 33. I press enter. And I get these z-scores. And what we did is we made a chart. We actually made a scatter plot Tell the person next to you, what shape do you think the scatter plot made if it was normal? Go ahead, make a guess. Tell the person next to you, what do you think?
Yeah.
Okay, so this is all I'm wondering. I know I have to show the example, but do you remember this piece that we said that if it made approximately a line, then we would say it was normal. If it was a curve, then we would say it was not normal. Okay, so we check the data. We feel like it's normal. We can go ahead and use our t-test stuff. Let's go ahead to where we were yesterday. Can you guys tell me, what did we have for x bar? 3 what? 320 what? 1.39? And what was the standard deviation we were given? 2.726. And we have to divide that by what? The square root of 33. So I'm going to go ahead on my calculator, and I'm going to take 2.726. And I'm going to divide it by the square root of 33, and I get 0.4745. And so what we're going to do now is we are going to build a confidence interval. And the confidence interval is x bar plus or minus our t-score times the standard deviation of our sample divided by the square root of our sample size. So x bar, which is, in this situation, 321.39 plus or minus, we already figured out standard deviation divided by the root of n, and we got that to be 0.4745. How do I find the t-score? You could go to the sheet, or you could go straight to this guy right here and go to the bottom and grab a t-score. Confidence interval. What's my confidence interval? 95, so I type in 0.95. What is my degree of freedom? 32 is 1 minus the sample. And so I got 2.037. Now that we have that information, we can go ahead and build our confidence interval. Can somebody take 2.037 and multiply it by 0.4745? .9665. Okay. So from there we could take the 321.39 and subtract the 0.9665. And I get 320.42. $322.356. One thing we didn't do yesterday, I want to make sure we say today, and that is the interpretation piece of this is very important. What does this mean? It means we are 95% confident that the mean amount. Ben, you have something to share with the class?
No.
that the mean amount of active ingredient is between 320.42 and 322.356. That's what that means. We're 95% confident. Statistics doesn't give exact answers. It gives our best indication that we have. And hopefully that's good enough. You know, you could say that, if the people making the pills are like, well, we need at least 320, then we're good to go. And they would be confident in that scenario. Okay? If you want to know about pills, talk to Harsh. He's the drug dealer. So, well, that's on YouTube now, isn't it? All right. Way to go, Harsh. All right, so final question of this unit, and question I have for you, okay? Are some students in some schools different than students in other schools? For example, if we did a random sampling, say, of, let's say, height here at Albert Lee, and we did a random sampling of height, say, in Austin, what do you think? Do you think that they're the same, or do you think that they're different? You know what's interesting? Because I asked this question a while ago when I first came to the district, and I was told how low our MCA scores was by our administration. And they told us, and this is how I entered the school district, they said, the reason why our MCA scores are as low as they are is because our teachers don't know what they're doing, and we need teachers to do a better job. And when I got here, I was expecting to see teachers who were just not very good and not qualified. But I found that teachers were pushing people. They were teaching them well. And I'm like, wait a minute. I feel like we're doing a decent job. So what is one of the line factors here that is maybe contributing to this? So I actually did a statistical analysis, and I started saying, well, I wonder what makes our community different than other communities. Anybody like to suggest something that makes Albert Lee different than, say, what other community should we pick? Winona. Let's pick Winona. How is Albert Lee different than Winona? Okay, so I plotted against income. And I saw that there was a correlation, but it wasn't necessarily super strong. Anybody got another one? What does Winona have that we don't have? A college. In fact, when I plotted data of Albert Lee against other schools that had colleges, without a doubt, Mankato, Rochester, Winona, and as you went up the cities, towns that had colleges, generally speaking, they were performing better than we were. And I went along those lines. I looked at something here. And I found something. And the statistic is still quoted in the district today. Nobody gives me credit for it. I was at a group like 3 different times where the superintendent spoke it out loud to everybody. This statistic. I was the one who set it off. But you'll be surprised by this one, okay? Because I think that this is what is unique. And I want to be clear, you guys. I choose to still teach in Albert Lee. I think it's a great place to teach. But this is an interesting statistic. I want to know what you think about it. Do you agree that if your parents were in college at some point, that education might be valued a little bit more in your house than if your parents didn't go to college? Is that true in every case? No. My parents did not go to college, and it was definitely important in my family. Okay? But would we agree? Got a lot of parents who went off to college. So I looked. The percentage of people ages 25 to 65 who have a 4-year degree. People 25 to 65 who have a 4-year degree. You agree 25 to 65? Those are the ages of people who have kids in the school district. I looked at that on the U.S. Census. What do you think is average in the state of Minnesota? Percent of people. It was 30%. Okay? What do you think the number was for Edina? 65%. Stillwater, 56%. Winona, 38%. Rochester, 46%. Mankato, 35%. Owatonna, 30%. Austin, 28. Albert Lee. You said it. 14. The only other school district I can find anywhere near close to us was Blue Earth with 14.7. Now, hey, I'm just saying that's just data. You know what I'm saying? But what it tells me without a doubt is that, people maybe didn't pursue as much education, right? And that's okay. That doesn't mean that you're not going to pursue, but it does put a little bit of a difference, okay? Now, finally, what is drawing people to take jobs with education in Rochester? Mayo Clinic, right? Absolutely. So that's something that your community has started to work on, saying, hey, as we want people with education to move here, we need jobs that require some education. And so that's been part of the movement back and forth that the community has talked about. So let's look at this example. Local school district thinks that their boys are shorter on average than the boys in a neighboring community. Do you think if we sampled the boys at Albert Lee, do you think there would be a difference in the height of the boys at Albert Lee compared to the height of the boys at Mankato East?
Yeah.
I think that there is.
Yeah.
People say I'm nuts. I think that there is. I think I could prove statistically. So how would we do that? It says that they just sampled one kid at random in grades 1 through 8. Now obviously you could do a lot better. I didn't want you guys to get a ton of numbers. I just want to be 8. Everybody good with that? So height in the neighboring community, 43. In this community, it was 44. 46, 45, 48, 46, 50, 59. This number here should not be 59. I mistyped that. That should be 50. Cross it off, make that 50. 52, 51, 56, 56, 59, 55, 64, 61. There it is. So I'm wondering about their difference. Difference is equal to the neighboring community minus our community. Like if there's a positive difference, that means that the neighboring community is taller. Agree? If it's negative, that means we're taller, right? So let's find the difference. Open up a Google Sheet to a blank spot.
Just said that.
So there I am on the blank sheet, and I'm just going to type in the 43, the 46, 48, the 50, 52, 56, 59, and 64. This is a problem you want to make sure you know how to do. This is part of your assignment. It's important we learn to start to work with differences. That comes up in our next unit, heavy on differences. And the next column, I'm going to put the heights in our community. 44, 45, 46, 50, not 59, my bad. 51, 56, 55, and 61. Now, if I want to know the difference, what do you think I should do with these two sets of data?
Well, like you add like your own column and then subtract them.
We're going to subtract them, yeah, exactly. So I'm going to take this column right here, and I'm going to write an equation for subtraction. Watch how I write the equation for subtraction. It's very easy. Press the equal sign, and our first cell is A1, so type A1. What do we want to subtract from A1? B1. So go minus B1. And press enter, and everybody make sure that you get -1 out of that. And then, as Tegan said, you can autofill or go Control D, and now we'll get the subtraction down the rest of the way. Could you also compute that by hand? Yeah, it wouldn't be any big deal. So, what we want to look at is we want to look at the mean as well as the standard deviation of this data. So, I'm going to go equals, and I've got the average, and I'm going to go equals, and I've got standard deviation. Everybody okay with these? All right, let's go ahead and let's make use of them, okay? I need the following then. In this problem, I have the x bar is equal to, was it 1.25?
Yeah.
And we're going to say that the standard deviation is equal to the standard deviation of the sample. What was the standard deviation of the sample? 1.66 divided by, how many samples did we have? 8. Okay. We don't have a known standard deviation of the problem. Our standard deviation is coming from the sample, so we have to use a t-score as opposed to a z-score. And so we have x bar plus or minus the t-score times the standard deviation of the sample divided by the root of n. So x bar, which is 1.25, plus or minus, I got to figure out t. So to figure out t, and it's 95%, I go to my t-score, 0.95. What is my degrees of freedom?
7.
7. So I go up here and I type 7. And I get 2.364. And that's what we would like to calculate. 1.25, oops, sorry, 2.364 times 1.66 divided by the square root of 8. People get 1.57? We're okay with that? So, we are 95% confident that the difference in height is between, so I'm going to take 1.25 and I'm going to add that to 1.75 or 57, excuse me, and I get 2.82. And then I'm going to take 1.25 and I'm going to subtract 1.57 and I get negative 0.32. Talk to the person next to you. What do you think we would conclude? Do you think we would conclude that there is a difference in the height between the two communities, or that there is not? Go ahead, talk to people next to you. What do you think?
Yeah.
The little red dots.
I'm not lying. I'm not lying. That's what more.
Statistically, this is the answer we would give. We would say there may be a difference, but there's not enough evidence to say for sure. For example, suppose that the heights were the same. What would we expect the difference to be? 0. And is 0 included in our confidence level? Yeah. So this confidence level tells us there might be no difference. In fact, part of our confidence level says that the people in this community might actually be taller. What do you think we would do to our study if we wanted to get a better handle on this? Sample more people, more ages, more grades, be more specific. It's leaning towards that we definitely seem to have the shorter kids, but it's not for sure by any stretch of the imagination. 0 is part of the confidence interval, so therefore we really can't say that one is taller than the other. Okay? Not a lot of certainty. Okay, go ahead and take out your homework. I gave you the worksheet yesterday. I made the answer key. If anybody has already gone through some of the problems, if you would be able to check to make sure we got the same, that would be great, because I'd like to take these and then post them online so people can access them. Problems 1, 2, and 3 are just like we did yesterday, whereas problem 4 is a different problem like we did today. So, you guys got about 10 minutes to be able to work. I'll come around and help you.